the difference in means of two normal distributions, variance known.
So here, for the variance known is that we should have the two populations represented by a sample mean
1 minus sample mean 2.
which they are independent, and both populations are normal.
For the steps for this kind of problem, first we should state the null hypothesis and the alternative hypothesis. For the null hypothesis, we assume that population mean minus population mean 2 is equal 0. For the alternative, that population mean 1 is greater than the population mean 2. For the second step, we choose the level of significance. For this problem, the chosen significance is the critical value of 0.05.
So this is our problem. So for the given standard deviation in our problem, we have 8, which we will raise to 2 because of the squared that we have on the formula. So we have n and n2, which is equals both to 0. And then we have our first sample mean, which is 121 minutes, and our second sample mean is 112 minutes.
This formula is for the double
Hypothesis
testing. So for the formula, z is equals to mean 1 minus sample mean 2 over square root of standard deviation of the population squared 1 minus over number of 1 plus standard deviation of the population squared 1 over n2.
So here we have 121 minus 112 over the square root of 8 squared over 10 and plus 8 squared over 10, which is equals to 2.52. So we have our significance of 0.5, which in the Z table has
A critical value of 1.645.
So here we have that Z is equals to 2.52, which is greater than our significance.
1.645.
So we reject the null hypothesis, which is the population mean is equals to population mean at the significance of 0.05.
And for the phi value, we have 1 minus theta times 2.52 equals to 0.0059.
That's all.
Hello guys, so partner, what is our topic for today?
So our topic for today is about inference for a difference in means of two normal distributions, variance unknown.
That's a very good topic.
Yeah.
Well, do we have any problem so that we can solve it today?
Oh, we are well prepared for that.
So let's start. So as you can see, this is the null hypothesis. So as you can see, it has an equal sign. Therefore, it says that it's a statistical hypothesis that contains a statement of equality. So you can see that it has an equal sign. And next to that is the alternative hypothesis, which has the sign of inequality, which says that in the definition, it is the complement of the null hypothesis. So after that, this is 0.05. So what we are going to do is to use the formula for test statistics. So partner?
So for this part, the test statistics, we should first subtract the population mean of 1 minus population mean 2, and then subtract it also to 0. Then divide it to 1 over the sample size 1 plus 1 over the sample size 2.
So given the values as 92.255, and for the population mean, for the second set of population mean 92.733. So the S1 is 2.39, S2 is 2.98, and this.
So we already finished with that, and now we are ready to derive that to get our answer. And for that, the standard deviation sample, we should equate this to the formula of sample size minus 1 standard deviation squared plus sample size 2 minus 1 standard deviation squared of 2. Then divided to sample size 1 plus sample size 2 minus 2. Then substitute all the given info to the solution. And then from that we get the variance of sample population. So we equate that to square root of 7.30. Then we get the 2.70.
And now for the formula of this a while ago, we must substitute these values in order to get the final answer. So 92.2255 subtracted by 97.733 over 2.70 square root of 1 over 8 plus 1 over 8, which is equal to negative 0.35.
Since the negative 2.145 is greater than to the test statistics, we get the null hypothesis cannot be rejected.
So that's it. Hope you enjoyed.
So hello everyone. I'm here to discuss about inferences of the variances of two normal populations. So here's the problem. Okay. So the problem says two different mixtures of gases are being studied to determine whether one is superior in reducing the variability of the oxide thickness. So we have to know if there is any evidence to indicate that either gas is preferable. So in order to do that, let's set a hypothesis. For our null hypothesis, the standard deviation squared of the sample 1 is equal to the standard deviation squared of the sample 2. And our alternative hypothesis is that the sample of the standard deviation 1 squared is not equal to the standard deviation of the sample 2. So you're given with alpha of 0.05. So we are given with two equal sample sizes, which is 20. And the standard deviation of the sample 1 is equal to 1.96. 1.96 squared is equal to 3.84. And the standard deviation of the sample 2 is equal to 2.13. And it's 2.13 squared is equal to 4.54. So in order to solve for our test statistics, we have to equate it to the sample 1 squared over sample standard deviation 1 over the sample standard deviation 2 squared, which is equal to 3.84 over 4.54, which is equal to 0.85. Since 0.85 is greater than 0.40 and 0.85 is less than 2.53, it doesn't fall into the rejection region. So therefore, we cannot reject the null hypothesis, and thus there is no sufficient evidence that there is a variability in either gases that it affects the oxide thickness of the product. That's all. Thank you.
Our topic is all about inference of two population proportion, which is this.
So our problem tells us about the null hypothesis, which is the population 1 is equal to population 2, and the alternative hypothesis is the population 1 is not equal to population 2. Since this problem is a total problem, the significance value of 0.05 will be divided into 2. That will be 0.25, and the z-score value is 1.96. So the given population success is 0.27, and the other success is 0.90. The sample size is equal to 100. So for the p-hat formula of the two population success is x1 plus x2 is divided into n1 plus n2, wherein 19 plus 27 divide 100 plus 100 is equal to 0.23. The formula
getting the z-score is population success 1 and minus population success 2 over square root of population success times 1 minus population success times 1 over n1 plus 1 over n2.
So by using that formula, you can substitute the variable that you have. By substituting the success 1 is equal to 0.27 minus 0.19 and over square root of 0.23 times 0.77 and times 1 over 100 plus 1 over 100, which is sample, is equal to 1.35 z-score. Since the z-score is 1.35, does not exist. Z-score 0.025, we cannot reject the null hypothesis. The p-value is equal to 0.177.